equivalent statement. So let us continue with one more example of an equivalent statement. Okay, so we say two statements are equivalent if the truth tables turn out to be the same. In other words, the last column of the truth table should be same for both the statements. Okay, so let us see some examples on this. Show that the statements show that the statements P implies R and Q implies R is equivalent to implies to P implies Q and R. Okay, so if P implies R and Q also implies R, wait, what did I write? Oh, sorry, I wrote this wrong. This will imply that P or Q implies R. Okay, let me just see this. Yep. So what is this statement actually telling you is, if P happens then R happens, right? If Q happens then also R happens. Okay, so if you combine both the statements, if either P happens or Q happens, then R will surely happen, no? Yeah. Okay, so if either P or Q happens, then R will surely happen. That's what we are saying over here. Okay, so let us prove that the statement is true using truth tables. So let us start with the truth table here. P, Q, R, P implies R, Q implies R, P implies R and Q implies R. Now this will be P or Q. Oh, no, wait. I have to build two more columns after this, huh? Okay, so P or Q, and next will be P or Q implies R. Okay, this last one is P or Q implies R. Okay, so let me draw the columns. P, Q, okay. What's going on there behind? Okay, wrote all the columns. Now let me just adjust little. So what are the possibilities? All are true. First two are true, third one is false. Okay. First one is true, false, true, true, false, false. Okay, then false. Then once I start changing this to false, now just repeat the above four entries again. So true, true, false, true, false. Okay, false, false, true. Okay, and then false, false, false. All are false. Okay, so now P implies R. So when is P implies to R true? It's always true except for the case when the first one is true and second one is false. Okay, so here true and true is this. So this is true, true and false. So this is false. True and true. So true again. True and false again here. So false. False and true. True. False and false. True. False and true. Still true. False and false again true. Okay. Next, Q implies R. So when is this true? Always true except for the case when the first one is true and second one is false. So here we have true implies true, so it should be true. True implies false, this should be false. False implies true, that is true. False implies false, true. True implies true, true. True implies false, this should be false. False implies true, true. Okay. So now end of both the statements. When is end true? When both are true. Okay. So true, false here, true again, false, true again, false, true, true. Okay. Now when is all true? When either one of them is true. So okay, P or Q we are doing. So one of them is true here, both are true here, both are true in the first case also. Somebody is true here, true here. It's going to be true here also, and true here also. Only the last two cases are false because both the P and Q are both false in the last two cases. Okay. Now this is P or Q implies R. So this is the first entry and this first statement is this. Second statement is this R column. Okay. So this is true. This is also true. So result is true. This is true. This is false. Result will be false. Okay. True. 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 True over here. False over here. So result should be false. So true over here. True over here. True. True and false will give you false. False and true, true. True again. Okay, are the columns number, is this column same as this column? Yes, no? Okay, both these columns are same and hence the statements are equivalent. Write down. Since column number 6 and 7 are equal, we can say that the statements are equivalent. Okay. Eh. Ali sir ki. Okay, done everyone. Okay, so let's go to the next thing. There are many other equivalent statements. I'll give them to you later. So, next subtopic over here is satisfiability. Satisfy satisfiability. Okay, so basically we are discussing whether a statement will be satisfiable or not. Okay, okay, so definition: a compound proposition is said to be satisfiable, if if it, if it is true, if it is true for some values of the values of for some values of truth of the variables. Okay, so basically what is a satisfiable proposition? A proposition which is true for some, at least one value of the this thing, uh, dependent variable truth values. Okay, so if p is true or false or whatever, no, for some value that compound statement should be true. Okay, so like for example, p implies r. P implies r is P implies r. When is this one true? This one is true in almost all cases except for true implies false. Okay, so this is a satisfiable statement because it is true for some case. Okay, then last time we had seen some statements like this. We had seen this statement. P implies r is satisfiable. Okay, because it's true for three cases when p is true, r is true, p is false, r is true, and p is false and r is false. These three cases it is true. Okay, clear? Last time we had seen one statement, p and not p, right? In last class we had seen this, no, before going home. Is this a last class we had seen this statement, no, before going home? Just check your last class notes. Is it true anytime? Always false, right? Okay, so this is not, it is not satisfiable. Okay, because it is never true. Okay, so for a statement to be satisfiable, it should be true for at least some values of on this thing. Okay. No, even if you don't talk about satisfiable things, like for example, let us just talk about some compound situations. It's based on some real life this thing. 6 3 7. Okay, so consider the statement: it is possible to score in an innings okay, or in other words, just to reduce the complications, it is possible to score 6,000 runs in a 50 overs. Okay, that's what I'm trying to imply over. Is it possible? Huh? No, right? Even if you go for the worst case scenario that you hit a 6 on every ball, is it still possible? Huh? If you hit 6 on every ball, how much you'll get, by the way? 300 balls are there. 1,800 you get, right? Yeah, so even if you, huh? Yeah, now actually there is a possibility that you can go for no balls. 1,800 is not the maximum score, right? So you can still assume no balls over there, right? Huh? Wides also you can assume. By the way, there is a limit on the number of extras a bowler can bowl in 1 over. Yeah, otherwise the bowler gets changed. Huh? कितने? No, if there are more than 3 extras in a over, the bowler is changed or something, huh? There is a rule like that. Huh? I doubt you can actually do that. No, I think so. If you ball more than 3 no balls, the bowler is changed. By the way, but I'm not sure. I'm not sure if the snowball is defined as the overstepping or the height over height. Huh? If you, yeah, if you hit more than 3 bounces and over, that changes the bowler, right? Huh? Yeah, there's a timing also for the match, no? Yeah. There's a time for the game. Yeah, so if you keep on bowling no balls, how will score runs? Yeah, bowler will get tired on the other side. Yeah, so this is possible, huh? I mean, this is not possible. Actually nowadays, for cricket matches they keep reserve timings also, but in the 90s they used to not keep reserve timings and all. So if the rain delays, then they used to directly cut the overs and all. Now it is not like that; they delay the match actually. Yeah. So actually this is not possible. For this statement to be possible, okay. So this is not satisfiable, we'll say. Okay. Uh, Everybody over here understands basic cricket at least, no? So cricket kotta mare. Good children. Everybody understands basic things of cricket, no? No. Okay, I'm saying now you can score 43 runs in an over. Is this possible? Yeah, this is possible, no? If you actually get one no ball and a free hit on it. Right, no? Why require free hit? Don't require free hit. So how will this be possible? On the first ball you should get a 6 and a 6, right? And 6. Magi no ball galya. No ball plus 6 on that no ball, huh? Six and 6. That only 43. So this is satisfiable if you get this. This has never happened, no, but I think the highest is 41. No, highest is 37, I think so, in one over. Somebody has hit 37. Huh? That is 36. कौन है 48 काढल्या? When he got 48? No, 48 is too much, Ray. I'm not sure, but somebody has gone beyond 36, that I know. Yuvraj Singh is exact 36. Huh? Okay. Okay, you all got the point now. Okay, so end of example. So let us go back now. So observe that observe that what did we discuss? It's a compound proposition is satisfiable if and only if it is a contain okay, it is a total. It's okay. So a compound proposition is satisfiable if and only if it is a tautology or a contingency. A tautology is always true, right? Okay, so it's automatically satisfiable. So contingency takes sometimes true, sometimes false values. Okay, so it is satisfiable because sometimes it is true. Okay. Okay, another thing is a contradiction. A compound proposition basically just observe that the statement which I am writing now is the negative of the previous statement. A compound proposition is not satisfiable if and only if it is a contradiction. Okay. Okay, so compound proposition is a this thing. A compound proposition is not satisfiable if it is a contradiction. Everyone agrees that this is a negative of the previous one. So I wrote satisfiable, I wrote not satisfiable. Okay, then it is not satisfiable if it is not a tautology or a not a contingency, right? But not means will not tautology or contingency will become what? It will become a contradiction because there are only three options over there. First, compound proposition will either be a contingency, tautology, or a contradiction. So if it is not a tautology or a contingency, then it has to be a contradiction, right? Okay, if it is none of the two options, then it has to be the third option. Okay, so moving on. Okay, so next is we'll see one example here. Okay, one more example I'll give you all. You can reach Margao in 25 minutes. Okay, how much time it takes? That staff shuttle bus takes 45 minutes, that I know. Nobody has taken less than 45, no? What 40 angela? No, it might be possible 35 if you do something stupid. Yeah. 30 minutes, 30 minutes. Who has managed 30? Okay, so let us see, for you to reach in 25 minutes, what are the conditions which are required over here? Now this is the conclusion, okay. Now what are the ways by which you can achieve this thing? Okay, so one thing is you have a fast bike or car. None of you all have a helicopter, so why we are talking of that? Huh? Okay, so you have a fast bike or car. Okay, we'll have to adjust with the bike only because huh? You have a fast bike. See. Okay, chalo, we'll adjust with a super bike. Okay, so you have a fast bike. A car won't be useful because you will get stuck in some traffic jam. You can't adjust. Not even fast bike. Huh? Which traffic ray? What match? Who goes to watch those matches? Tumo idai. Who goes to watch those ISL matches, man? See. कौन लोग होते आता स्टेडियम बत्ता. It's like the ISL has become so boring now that even the newspapers have lost interest in reporting about it. I even forgot who won the last ISL. Who won? There was last ISL. बेजार आइला नहीं. Okay, so you have a fast bike. So how much fast you'll have to drive? What is the distance, by the way? Distance around 40 kilometers, no? Huh? I think so. You'll have to drive at around 80 kilometers hour average speed, huh? Or you have a fast Splendor. See, who does tuning of Splendors over here? कौन है? स्प्लेंडर अशी मस्त ट्युनिंग करता लोकशी. You are driving a 98cc bike at 200 kilometers per hour. कौन तो? कौन तो? Who's your tuning garage, by the way? Okay, you can drive it. What 390cc Splendor? Okay, what else is required? Traffic is less. Okay, Aniket Zay, what are the conditions you require? Yeah. ये रास्ते बरे नाही, actually you'll have to adjust with the Himalayan or something. हाँ ना हायवे तिथली बरी नाही रे ती.
Good road, no police.
No police, no traffic, no signal. That is same thing. What else you require?
No power.
Huh? No pause. Good weather.
Good weather. Good weather.
What else you require? Oh, God's blessings there, but good luck will say directly. Good luck for many other things. What else you require? Nothing, no? Huh? There is no speed camera on this highway. I was driving at 70, 80 that day. I didn't see anything. Hope there is no camera. Shit. No, on this highway there are not. The Margam Panjam highway there is not there. I think so. Oh, shit. I'll dirty my number plate and keep these days. मात पड मग सांगपाची पावसाची. होय. हा okay, so now the compound proposition is that you can reach Marga in 25 minutes. Okay, so for that statement to be true, so many, how many? 1 2 3 4 5 6 7 conditions have to be satisfied. Okay, so if all the 7 conditions are true, then only you will be able to achieve this. Huh? Yeah, no, see, they can be conditions like some conditions are necessary that you have to have fast bike. You can't do this on a Splendor. It is not safe to do this on Splendor. That way is better. Hey, by the way, what is Splendor's top speed? 120. Not possible, Ray. Doubtful. I love my life, okay? I don't want to test that experiment. Okay. Okay. Now see, one default condition is that you require a bit fast bike. Now assume there is a traffic is more. Traffic is also still required to be less. Now if traffic is more, then you can never achieve this, right? Right? Assume there are. Assume like halfway somewhere, like around there is traffic somewhere, like around say another Verna junction or something. There is traffic. Okay, so what you'll have to do there? You'll have to slow down, no? Okay, when you reach some main important junction, you have to slow down. then what you will do? So that statement becomes false, right? But can you still reach in 25 minutes? Hmm? No, you can. You should can drive at 120 then to cover up, right? You can cover up, no, like that. Hmm? By the way, what I'm writing here, no, this trains do this, by the way. If a train has to travel between Goa to Bombay, no, so there's a after the leaving time from Goa is fixed like at 2:30, and it has to reach Bombay in how many hours now? Short झाले 11 hours will count for Jan Shatabdi or something. Okay, what Jan Shatabdi takes around 9 hours, no? Where he wants to go? Okay, so it has to reach Bombay in say 9 hours or 10 hours, right? So if it leaves at 2 o'clock, it has to reach by कितल्या पावतली रे? Yeah, it will reach by 11 o'clock now if it leaves at 12 o'clock. Now see what happens sometimes is there are problems over here. They have fast engines, don't worry about the engines are very fast. Okay, and they are very powerful also. Okay, they are like around 25,000 cc and all. Yeah, yeah, 25,000. Volvo buses are by the way around 9,000 cc. Yeah. Regular buses, no, non-Volvo, the others they are like around 4,000 to 6,000 cc. So train engines in comparison are around 25,000 cc. So yeah, so they are fast enough, they can achieve 100, 110 and all. Okay, but now assume like something happens on the way. Okay, the train gets delayed in between, right? Okay, so now what happens is in between they have to cover up the speed by driving faster or doing something else. Okay, like some stations, if there is a 5-minute halt, they reduce it to 3 minutes or 2 minutes. Okay, to cover up. Okay, so something they do like that now, and they eventually they can reach Bombay by 11 o'clock. Okay, but still there are some other conditions involved over there, that the traffic also should be less and you should be getting priority on the tracks. Okay, that your train should be allowed to go in front of other trains and overtake the other trains and all. Okay, so it is possible on railway tracks, but on roads, no, it is little difficult. Yeah, yeah, because by the way, the trains have a standard speed of around 60 kilometers or 70 kilometers, right? So if the train is delayed, they can drive at 80, 90 and cover up. So that's how they manage it. Okay, and I have seen trains which have covered up as much as 4 hours like that, even after they are 4 hours late and all. But not Goa to Bombay, it's like 2 days journey, like it was 72 hours like that. Okay, so let us do one this thing using truth tables. Verify that. Verify if verify if P or not Q, P or not Q, and Q and not R, Q or not R, and R or not R or not P. Okay, so let us do the truth table for this. So P, Q and R you write down. Okay, then write down this individually. Write down each of the brackets, P and not Q. Okay, we'll have to do this now. P, Q, R write down not P, not Q and not R. Okay, then you write down P or not Q. Okay, then you write down Q or not R, Okay, and then you write down R or not P. Okay, and then this is the last combined statement, P or not Q and Q or not R and R or not P. Okay, try to fit it in one line if possible. Okay, so let us write down true, 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 both true, third one false, true, false, true, true, false, false, then false, true, true, false, true, false, 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 true, false, false, false. Okay, this will become false, false. I'm making negative, huh? So false, false, and this is true, 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 true. This is false, false, true, true, false, false, true, true, false, true, false, true, false, true, false, true. Okay, now when is all true, it is true when either one of them is true, at least one of them is true rather. Okay, so P and not Q. So I'm looking at the first column and the fifth column. Okay, first column and fifth column you look. Okay, one of them is true. Actually the first four entries are going to be true because P is true over there, right? And now next it is here it is false, here it is false, so this is false, both false here again, false and true, so true, true. Okay, last two are true, huh? Okay, Q and not R, so first second column and the sixth column. Okay, so true, 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 sixth column, false, true. True, yeah, sixth column, no? Yeah, yeah, so again Q is true, so this is also true. Next is R, false, true. Okay, so next is R and not P. Okay, so the third and fourth column, so this is very easy because they're close by. So true, false, true, false, true, all are true after this. Okay, and when is the end statement true now? End statement is true when all the individual people are true. So we are looking at end of 1, 2, 3. Sorry, the seventh, eighth, and ninth columns. Okay, so if all three columns are going to be true, then it's going to be true. So this is true, false, 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 true. Okay, so is this statement satisfiable? Yes, no? Okay. So the above statement is satisfiable when? So write down. The above. What was the question, by the way? No, no, no. The statement of the above statement. Above statement. What is that? P or not Q and Q and Q or not R and R or not P is satisfiable. When is it satisfiable? No, it is satisfiable. It is satisfiable because it is true sometimes or the other, right? More importantly, it is true when it becomes true, when P is true uh, and Q is true and R is true, or P is false and Q is false and R is false. Okay, only in these two possible scenarios the statement final answer becomes true. Okay, when either all your statements are true or all the statements are false. और ऐसा this way. Finished? हाँ हुंगाच पाहिजे रे तुका 25 मिनिट लागता म्हणून प्रूव्ह केला आम्ही ताजी स्प्लेंडर घेऊन वस okay. So with this we have completed this chapter, so now let us start with the next chapter. Okay.